means, so rate of change means a change in distance over time. Let's put the phones away. Phones, turn them over. Focus up here. Rate of change means some sort of distance, change in distance over a change in time. When I get in my car, I live 7, 8 miles away. So when I get in my car and I come here, that's a change in 7 or 8 miles, right? And if I were to divide that by how much time it took me to get here, 20 minutes, 25 minutes, whatever it is, that would be a rate of change. We call that miles per hour, right? I'm driving in my car. I look, it says 45 mph, 45 miles per hour. That's a rate. What does that mean? If I'm going 45 miles per hour, what does that mean? What's another way of saying that? Exactly. 45. If I were to keep that speed for 1 hour, not go any faster, not go any slower, I would be 45 miles further than where I started. That's what it means. Now, we don't do that, right? When you get in a car, you speed up, you slow down, right? There's traffic, there's stoplights, there's stop signs, right? So sometimes you can speed up. If you're going on Herndon or if you're going on the freeway, you can go a little faster than if you're going on, Shaw or Ashland. Those streets have slower. The traffic is slower. Okay. So rate of change is how fast you're going or how much you've traveled over a certain time. So what we're doing today, that's slope. What we're doing today is called average rate of change. That's from a start to a finish. From a start to a finish. How far did you go versus how long it took you, right? Rise over run. Rise over run. The top is how far did you travel? 10 miles, 20 miles, 5 miles. How long did it take you? 10 minutes, 20 minutes, 3 hours, whatever it took you. Okay? Now, we're not using that, but essentially that's what we're doing. That's what we're doing. Okay? So the formula here, y2 minus y1 over x2 minus x1, that's a formula you guys have been using since junior high at least. It's how to find slope. That's what we're doing today. That's all we're doing today. Okay? Okay, so two things. We need two things to find rate of change. First thing I need is two points in time. 2 points in time, 2 dots. When I started, that's one. When I left my house, when I got here, that's another one. I can find rate of change if I have 2 points, right? I need 2 points, an x and a y and an x and a y. Okay? Once I do that, I can use my formula. Okay. So there's 3 different ways they're going to give you. First one is tables. They're going to give you a table, x and y table. So they say f of x. It's the same thing as y. Why do they put f of x? Because they want you to know it's a function. They want you to know it passes the vertical line test. That's why they put f of x instead of y. Why do they put f of x or g of x or h of x? Because they want you to know it's a function. Okay? But essentially, f of x is the same thing as y. Okay? Okay, so given the function defined in the table, find the average rate of change in simplest form over the interval from 3 to 4. Okay, so the first thing I need is 2 dots, 2 points. So I need point 1, which is going to have an x and a y. And I need point 2, point number 2, which is going to have an x and a y. Once I do that, I can plug them into my formula. Okay. So using a table, you just look at the table. Where am I starting? Well, I'm starting at 3, finishing at 4. You notice how right in between the 3 and the 4, there's an x. That means x. So which point goes with when x is 3? Which point goes with that in the table? 3, 4, right? 3 comma 1. 3 is x, y is 4. That's my first point. Where did I end? I ended at 4. 4 was where I stopped. So that's going to go here. Okay. So at 4, what was the y value? 4 as well. That's my second point. Once I have those two dots, those 2 points, then I can use my formula. So how do I use my formula? Well, the top is y2 minus y1. So where do I find y2? Right there. The second point, second number. The y of the second point, which for me is 4. Minus y1. y1 is the y value of the first point, which is also 4, happens to be 4 as well. That's the y's. Now the x's. x2. X value for point 2. 4. Minus x1. X value for point 1. 3. Subtract. So on top I get 4 minus 4, which is 0. On bottom I get 4 minus 3, positive 1. What is 0 divided by 1? Yeah. I have 1 pi, and I get none. How much of the pi do I have? None. Yeah. What does that mean if I have an average rate of change of 0? It's constant. What else does it mean? If I have an average rate of change of 0, stays the same. So put me in my car. What does that mean? I'm in my car. Yeah. I got in my car. A minute later, I got out of my car. Where did I go? Nowhere. I didn't go anywhere. That's what average rate of change of 0 means. You didn't go anywhere. The only thing that changed was time. 1 minute changed or 1 hour. They don't say what 3 and 4 are. Is it hours? Is it minutes? Is it seconds? I don't know, but that's what it means. Okay? All right, let's do letter B now. Letter B. So we're going to use the same table. So I want you to change. So this 5 is supposed to be a 6. It's supposed to be a 6. I don't know why it came out 5, but it's supposed to be 6. So given the function defined in the table, same table, find the average rate of change in simplest form. This time we're going from 2 to 6. From 2 to 6. So the first thing I need is 2 points. Two and 6 are x's. How do I know they're x's? Because there's an x right here in the middle. So 2, 6. Go to the table. What y value goes with when x is equal to 2? 6. Is that right? Point number 2, which y value goes when x is equal to 6? 10. There's my 2 dots right there. Go back to my formula. Now, when I use this formula, I use parentheses. Why do I use parentheses? We haven't seen any yet, but you're going to get some negative numbers. And there's always a minus in between. Sometimes if there's negatives, the negatives and the minuses get mixed up and you forget which one's which. So that's why I just naturally always do that. Okay, so y2, 0.2y, 0.2, y is 10. y1, 0.1, y is 6. Now the bottom, x2, 0.2, x is 6, x1, 0.1, x is 2. 10 minus 6 is 4. 6 minus 2 is 4. If you can divide, divide. If you can reduce, reduce. These ones we can divide. We get 1. We get 1. Okay, done. That's how to do it using a table. Okay. The next one is using a graph. Using a graph. So let's go to number 2. How do I do the same thing using a graph? Very similar. The only difference is you don't have a table. Okay, so we're going to use the graph instead. All right, so 2a. The graph. So we're going to use the graph above. What is the average rate of change for the graph? When they say f of x, they mean the graph. For -6 to -2. Okay, so I need 2 points. So from -6, that's the first dot. That's the first point, and -2. What I got to go do is go figure out what y value goes with -6. I'm not going to use the table this time because I don't have one. I'm going to use a graph. So x is -6. That means I go left 6. Where's the dot? Up 4, right? So the dot, the y that goes with -6 is +4. 0.2, -2. So that means I go left 2. Where's the dot? Down 4. So the y value that goes with -2 is -4. Okay, plug them in. y2, -4. y1, +4. x2, -2. x1, -6. So now you have negatives. So that's why, again, that's why I do parentheses around all of everything so that I know the difference. -4 minus 4, -8. -2 minus a -6, double negatives, +4. If you can divide, divide. If you can reduce, reduce. Well, 4 goes into -8, -2 times. Okay, all right, do letter B now. Try letter B. Using the same graph, find the rate of change from -3 to -1 now. So this guy, we start at -3 and go to -1. So -3, comma something, to -1, comma something. So we got to go figure out what y values go with each of these. So -3. If I go left 3, -3, then to get to the dot, I'm going to have to go down 8. So -3, -8 is where the dot is. -1, now the next dot. -1 means left 1. To get to the dot, I'm going to have to go up 14. So the two dots here are up here and down here. Yellow to blue. Okay. Start with the second y. 0.2y is 14. 0.1y is negative 8. 0.2x is negative 1. 0.1x is negative 3. I got double negatives on top, double negatives on bottom. Reduce if you can. If you can't divide, you get 11. Okay. That's how you use a graph. Okay. That's how you use a graph.
So how does it turn to positive again? See how it is plus and plus 8?
Because if you're subtracting a negative, 14 minus a negative means double negatives make positives. So if you're subtracting a negative number, change them both to positive.
Mm-hmm. So I feel like negative 4, negative 3. Or like negative 1, negative 3.
Yeah, so if you're anytime you're subtracting a negative, you're always going to do it. Okay. All right, so the last one. The last one we're doing is if they don't give you a graph, they don't give you a table, they give you an equation. Okay. We still have a starting spot, though. We still have a start and a finish. Negative 3 is where we start. Negative or positive 4 is where we finish. So those are still going to be our x values. So 0.1, 0.2. 0.1 is negative 3, comma something. Positive 4, comma something. So I don't have a graph to look at like I did on the last one. I don't have a table to look at like I did on the first one. What do? Well, if you want a y value, plug in your x. So everywhere I see an x, I'm going to plug in negative 3 first. I'm going to plug in negative 3. So everywhere I see an x, I'm going to plug in negative 3. So negative 3 to the second power plus 3, times negative 3 minus 1. That's how you use the equation they've given you. Everywhere you see an x, plug in the number that you want. I want negative 3. What is the y value for negative 3? So I'm going to go to my calculator now, see what I get. Okay, so it's parentheses negative 3 squared, parentheses negative 3 to the second power, plus 3, parentheses negative 3, minus 1. When I do that, I get negative 1. So the y value for negative 3 is negative 1. So to start, the starting dot is at negative 3, negative 1. Left 3, down 1. How do I get the other one? Do the same thing. Plug in 4. Instead of negative 3, I'm going to plug in 4. 4 squared plus 3 times 4 minus 1. Everywhere I see a 4 or an x to the original, plug it in 4. Okay, so I'm going to go to my calculator, plug in 4. I already have the outline of it, so I'm just going to take away -3 and put 4 in. I get positive 27. There's my second dot. Write 4 up 27. Once you got your 2 points, use your formula. y2, 0.2y. Y for 0.2 is 27. Y for 0.1 is -1. x2, x for 0.2 is 4. X for 0.1 is -3. -27 minus a negative. Okay, so we have minus a negative. So minus a negative means adding. 4 minus -3. Again, minus a negative. Okay, so we're going to do, I got one more, and then I'm going to give you one more to do on your own, and then we'll be done. Okay, so number 4, example number 4. Okay. So I need 2 points. So this guy starts at -4, ends at 6. Those are my x values to start and finish. So now I need the y values. How do I get those? You're going to use the equation they've given you. Everywhere I see an x, the first thing I'm going to do is I'm going to plug in -4. Then I'm going to go to my calculator. Notice how the negative in front stays. The negative and the minus stay. This guy and this guy are still minus. Just because it's a -4 doesn't mean it cancels out. Those still stay. Okay, so let me go to my calculator. Negative, parentheses, squared, minus, parentheses, plus 3. So I'm going to put in -4 first. So when I put in -4, I get -9. So the first dot is going to be -4, comma, -9. Now the next dot, plug in 6 everywhere. I'm going to go back to I already have the outline of it. I just need to change -4 to 6. Positive 6. Positive 6. -39. So the next dot is going to be positive 6, comma, -39. Last thing, formula. y2 is 0.2's y. 0.2 has a y of negative 39. y1, 0.1 has a y of negative 9. x2, 0.2's x is 6. Minus x1, 0.1's x is negative 4. So negative minus a negative, I got to change those. I get negative 30 over 10. Which makes negative 3. Yeah. Okay. So I'm going to give you one more to do in your notebook. This is going to be example number 5. It's going to go on page 28. Page 28. When he gets back. Okay, here we go. Number 5. Okay, so from 1 to 10. So we gave us an equation, so we're going to plug in 1. Plus 7 plus 18. Okay. So the first number I'm going to plug in is 1. I get 24. So the first dot is at 1, 24. Right 1 up 24. Then I'm going to plug in positive 10. The next dot is at 10, negative 12. Positive 10, right 10, down 12. That's where the dot would be. Okay. y2 is negative 12. y1 is 24. x2 is 10. x1 is 1. So I get negative 36 over positive 9, which makes negative 4. Okay. I want to show you one problem. I'm not going to make you do another problem, but I want to show you because you're going to see it tomorrow. And eventually when we take quizzes and tests, this is the kind of problem I'm going to show you. So I want to show you another problem and see if you know what to do. It's not hard, but it's different. Okay. So if I was giving you a test, this is the problem I'd give you. How do I do this problem? The answer is you know, and I'm not going to tell you. So how do you do this problem? It's not hard. What's that? Say again? So you know it starts from negative 4 to 5. Well, what? From least to greatest. It means smallest to biggest, right? Well, how do I figure out which one's smaller or which one's bigger? So the first one, did we do a problem like f of x? Yeah, we did 2 of them, right? So do you know how to find the average rate of change for f of x? It's in your notes, good. The second one is a graph, or sorry, is a table. Do we know how to find average rate of change for a table? Yeah, first two problems we did. The last one, h of x, is a formula or equation. Did you do any in your equation on your notes that had an equation?
Yeah. Did you use any of them?
So how would I find rate of change using a graph? The same way you did it on your notes, right? So you know how to do this problem. You know how to do this problem. You know how to do this problem. It's just three small problems. They want you to compare your answers. When you do f of x, what answer do you get? When you do the table, what do you get? When you do h of x, what do you get? Which answer was smallest? Which answer was biggest? Which answer was in the middle? That's all they want to know. It's three small problems into one. Okay? You're going to see something like this tomorrow. And when we take the test or quiz or whatever we take, this is the type of problem I'm going to ask you because I want you to compare. You do one graph, one table, one equation, and then you compare your answers. Which one's biggest? Which one's smallest? Which one is... So it's like comparing your answers we got here. All of the answers we got, -2, 11, 4, -3. Which one was smallest? Which one was biggest? Which one was in the middle? That's all it is. Put them in order. Jafet asked first. Okay.
Would you please go back to the last problem?
Yep. Yep, number 5. Okay. All right.